Hello guys! This is my report of Group 9. But wait, good afternoon everyone. My name is Jericho lico from STEM 12 class. Okay, let's start first lesson. Ang first lesson na ituturo ko sa inyo, it's all about periodic motion. The introduction of periodic motion is a motion that repeats about a point of stable equilibrium. A necessary requirement for periodic motion is restoring forces. Keywords of periodic motion is amplitude, frequency, and oscillation.
Hello, good morning!
And again, nandito ulit tayo para ipagpatuloy ang lesson natin. Okay, ulitin natin ang 3 keywords ng periodic motion. Amplitude, frequency, and oscillation. Okay, the first is amplitude. What is amplitude? Amplitude is maximum displacement from the equilibrium position. The SL unit for amplitude is meter. The second one is a period, means this is the time for one cycle. The SL unit for period is second, pero minsan nag-express siya as a second per cycle. The third one is a frequency. This is the number of cycle in a unit of a time. The SL unit for a frequency is hertz. Last one is angular frequency. It's also known as radial. The equation is, this is the example of periodic motion.
Bouncing on the end of the spring has a period of motion 2 seconds. If the mass is double set in motion once again, what will be the approximate period of motion? So they are asking for the t, but they have provided the t before, that's equal to 2, and also they are saying when the mass is doubled, what's going to be the new t. So in this case t is equal to 2, so we know the equation for the t is equal to 2 pi or 2 pi into square root of m over k. So we can say this is equal to 2, that's what is provided. And the question is asking if the mass is doubled, so this is going to be 2 times. So if we write the new equation, that's going to be t is equal to 2 pi square root of 2m over k, and this is the new equation, and they are asking to find the period in this situation. So let's see how we can do this. So first of all, what we can do, we can, if we bring this pattern right here, we can substitute these 2. So let's try to bring this. So in this 2m, so we can separate this 2m as square root of 2 square root of m. So it's same thing, multiply by square root of m. So that's what I'm going to do right here. So this is going to be 2 pi square root of m over k multiply by square root of 2. And then what I can do, I can simply substitute this 2 for this value, and it's going to be 2 times square root of 2. We know that square root of 2 is 1.4, so 2 times 1.4, that's going to be equal to 2.8, and that's the final answer, 2.8 seconds. And that's how it's.
Okay, natapos na tayo sa unang lesson. Isunod naman natin ang pangalawang lesson. Ito ay simple harmonic motion. What is a simple harmonic motion? A simple harmonic motion is vibratory motion about an equilibrium position. Note about this. The acceleration of harmonic oscillator is provided that the angular speed with the reference of a certain point is related to the force constant and mass of the oscillating body. The formula of simple harmonic motion is W is equals to square root of k over m. W it means angular frequency. K it means force constants. M it means mass of the body. Note, F is equals to W over 2 pi is equals to 1 over 2 pi square root of k over m. T is equals to 1 over F is equals to 2 pi over W is equals to 2 pi square root of m over k, and 2 pi square root of L over G. This is the example of simple harmonic motion.
In this video, we're going to talk about how to solve some basic simple harmonic motion problems in physics. So let's start with number 1. A horizontal spring with a mass of 0.75 kilograms attached to it is undergoing simple harmonic motion. Calculate the period, frequency, and angular frequency of this oscillator. So if you want to try this problem, feel free to pause the video and work on it. The formula that we need to calculate the period is this equation. It's equal to 2 pi times the square root of the mass divided by the spring constant, which we have all of that in this problem. So the mass is 0.75 kilograms, and the spring constant is 300 newtons per meter. So let's go ahead and type that into the calculator. So the period is 0.3142 seconds. So that's how you can find the period of a simple harmonic oscillator. All you need is the mass and the spring constant. Now part B, what is the frequency? Frequency is 1 divided by the period. So it's 1 divided by 0.3142 seconds. So the frequency in this problem is 3.183 hertz. Now let's move on to part C. Let's calculate the angular frequency. The angular frequency represented by the symbol omega, it's 2 pi times the frequency. So that's going to be 2 pi times 3.183 hertz. And so that's going to be about 20 radians per second. And that's it for this problem.
Okay guys, last topic na to, kaya tapusin na natin to, pero matagal siyang tapos. Okay guys, the last topic is mechanical wave. What is a mechanical wave? A mechanical wave are waves that require medium. This means that they have to have some sort of matter to travel through. Wavelength denoted by, it's the length of one complete wave pattern. Wavelength is equals to velocity over Fahrenheit, where v is the wave speed and f is the frequency. This is the 3 types of waves: longitudinal, transverse, and sinusoidal waves. First is longitudinal wave. It's one in which the particles of the medium vibrate parallel to the direction of the wave propagation. Ang wave is nagko-compose siya as comprehension and refraction. The example of longitudinal wave is sound wave. Longitudinal wave, it means parallel. Transverse wave, it means perpendicularly. The last type of wave is sinusoidal wave. The value of y is nakadepende siya sa particle that are talking about. Y, it means function of x, and on the time is complete one whole period. Thus y is function of both x and f. The equation of sinusoidal wave is y is equals to a sine times 2 pi over a times x minus vt.
So the question is, the equation for a wave is given by y of x and t is equal to 2 sine 3x minus 4t plus pi on 2 meters, where x is in meters and t is in seconds. Find the A, amplitude, B, frequency, C, wavelength, D, speed, and E, initial height at x is equal to 1.0 meter. Okay, so in order to do this, what we'll want to do is equate this equation to our equation for a wave. Y of xt is equal to a sine kx minus omega t plus phi. Okay, so we can see because it's got the negative sign here that it's a wave traveling in the positive x direction. Now the amplitude, that's given by this letter capital A here, and that is the number out the front. So the amplitude is equal to 2 meters. Now to find the frequency, we're going to need to look at omega. Omega is in front of the t, so we know that omega is equal to 4.0, and omega is also equal to 2 pi f. So this tells us that the frequency is equal to 4 over 2 pi, and so we can solve that and we get 0.64 hertz. That's the answer to B, is the frequency. So 0.64 hertz. Now the wavelength, C. We know that K, the wave number, is given by 2 pi over lambda, and this is equal to 3. So this tells us that lambda is equal to 2 pi on 3. So we could just give this as 2/3 pi, or we could solve it on the calculator, in which case we get this is equal to 2.1 meters. So the wavelength is 2.1 meters. The speed, d, we've got v is equal to f lambda. So we could just multiply together our f and our lambda here, or we could use the other equation that v is equal to omega on k, and we know that omega is 4 and k is 3, so this is 4 over 3, and so that is equal to 1.3 meters per second. So this is 1.3 meters per second. And then in part E, we're asked to find the initial height at x is equal to 1.0 meters. So initial tells us that t is equal to 0. So what we're trying to find is the height when x is equal to 1 and t is equal to 0. So we need to substitute 1 and 0 into this equation. So this is going to be 2 sine. Now we'll have 3 times 1 minus, well, 4 times 0, that's 0, plus pi on 2. So this is going to be equal to 2 times sine. Solving this, we end up with 4.57. And we solve this on the calculator. Now it's really important to remember when you put this into your calculator that your calculator needs to be in radians mode, because all these terms in here are given in radians. So if we have our calculator in radians mode, then we find that this sine function here is actually equal to -1. So we end up with an amplitude of -2 meters. So that'll be the lowest point on this wave.
Hello guys, my name is Jericho, and thank you for watching my video.